In this next problem, we're asked to find the extreme values, which again means the mins and maxes of this f of xy, where we have our boundary. They're going ahead and telling us that it's closed and bounded, but it is a triangular region with vertices, so it's giving us some points. So what we can go ahead and do is go ahead and draw a picture of our boundary here. So let's go ahead and draw a picture of our boundary. And remember, this is going to be an XY. So let's go ahead and see what this would look like. So the first vertices at 2, 0, which means 2 on the x-axis. And then our next vertices at 0, 2, which means up on the y-axis. And then 0, negative 2, which would be down on the y-axis. And so let's see what this triangle looks like. And last but not least, this last side. And it's not perfect, but you guys get the idea. So we've got a line 1, a line 2, and a line 3 here. And we know that our function is continuous because we're not worried about square roots or denominators. What we do need to do is we need to work on our critical points that are inside of our bounded region. Because remember, our bounded region here is everything that's inside this triangle. And then we also will have to worry about the boundary, but let's deal with anything inside of the triangle first, which means finding our critical points. So let's find the critical points first. So let's find the critical points inside our boundary. And they were going ahead and calling the boundary D. So that's the shaded figure along with, again, the closed part around the boundary. But one thing at a time, we're dealing with our critical points first. So 1, we're dealing with our critical points that are inside D. Okay, so critical points means that our first partial derivative with respect to x and our first partial derivative with respect to y need to both equal 0. So our original function, let's see, f of xy is equal to x squared plus y squared minus our 2x. So if we find our partial derivative with respect to x, treating our x as our variable, let's see, that means we're only worried about these two terms. So finding the derivative would be a 2x minus 2. Then we'd also want to find, and besides this, we'd also want to find our partial derivative with respect to y, which means that we're going to now take the derivative where y is our variable, which means we're only worried about that y squared term. Everything else will be considered a constant, so their derivatives will be 0. So we're just worried about the y squared, whose derivative is 2y. Remember, what do we want for critical values? We want both of their derivatives to equal 0. So be careful, this is an and situation again. So solving these two equations, we'd add 2 to both sides on the left-hand side equation, then divide both sides by 2, which gives us 1. And then dividing both sides by 2 gives us y equals 0 over 2, which is just 0. So what does this mean? We need both of these to be true. So that means that 1, 0, the x value with 1, and the y value is 0, is a critical point. So again, we're gathering all the points that we need to examine for being mins and maxes. First, we start out with the critical points. Next, we go after the boundary. So next, we go after the critical points on the boundary. So next, we're going after the boundary. Well, let's take a look at the lines for the boundary. So let's take a look at a copy of our picture. Let's see. Let's take a look at this. Look at a little bit of a smaller version of it. And let's look at list or L1, our line 1, which has, if we look at this, line 1, this guy, is gonna be, if we were to come up with an equation, it's a vertical line. So it's gonna have x's. So it'll be x equals, well, it's at the x value at 0. So if you go and look at your number line, it has an x value of 0. So let's see, at 0, so it'll be x equals 0. Okay, so what would we use for, remember we need a parametric equation. So we can use an r of t. For our parametric equation, remember we need components, a 0 for our x and just a t for our y, because the y values do change. The y values range, if you go in back and look at our picture, our y values range from down here at -2 to up here at +2. So then what we're going to say is where t is in -2 to 2 for the y values. So that's your first line. Then we can look at our second line. Our second line here, looking at that guy, is this line. And let's see, what do we know about that line? Well, that line has a negative slope. And let's see what its slope is. It's going down 1 over 1, so its slope is -1 out in front of your x, putting it in slope-intercept form. The y-intercept is up here at 2, so it'd be +2, just using slope-intercept form. So if you were to write this a little bit nicer, this could be rewritten as -x + 2. You don't need to write the 1. So what would we use as our parametric equation? So we can use an r of t for this second line. Remember, we're going after the second line here. Of, let's see, t is going to be our x's because our x's are changing. And then be careful. Let's talk about what our t's are before we move on. Where t is between, if x is going to be our t values, then let's see, or if t is going to be our x values is a better way of saying it, then it ranges from 0 to 2. So we'll have our t's between 0 to 2, the same as our x values, because it's going to be our x component, comma. Then our y's will be whatever we are getting out for y, which is our -x + 2. But remember, what are we using for our x? We are using t for our x, so we can just swap those. So what we'll go ahead and have as our equation here is negative, again, swapping our t's and x's, so that's a parametric equation. It'd be t + 2. So there's our parametric equation in component form for our second line. Now the third line, L3, let's see, that one would be looking at, let's see, this one. L3 is very similar to the last one we just did. It's a y equals, and let's use slope-intercept form, except for this time the slope is that we're going up 1 and over 1, so the slope will just be a +1, x, and then our y-intercept here is, be careful, it starts down here at -2, so -2. So we don't need to write that 1 out in front, so it'll be just x minus 2. So our parametric equation would be r of t. And let's go ahead and let our x component be t again. And be careful, let's go ahead and figure out where our t's are. Where t is in, let's see, remember our t's here, which would be our x's, are going to range from 0 to 2 again, just like the last line in parametric equation for that line, and comma. Now again, just like the last one, we are using t as our x, so we can just make that swap. So we will have, let's see, a t minus 2 instead of an x minus 2. And there's our parametric equation.